Hello, Satish sir, am I audible?
Yes, sir,
Hello,
it's audible, sir.
yes. Good evening, all. Welcome to day 4 of ATAL Online 6-day FDP on intelligent systems and generative AI, advancements in deep learning, robotics, and applications. Good evening. I am Samuel Sandeep, Department of CSC Aliet, Andhra Loyola Institute of Engineering and Technology. Take privilege to introduce today's resource person, Dr. Nagaraju Vaideti, Assistant Professor, Grade 1, Level 12, Department of Computer Science and Engineering, National Institute of Technology, Nagaland. And sir has completed his PhD in Computer Science and Engineering from National Institute of Technology, Nagaland in the year 2019. And he has completed his MTech in CSC from College of Engineering, Andhra University in 2008 and completed his BTech and CSC from College of Engineering, Andhra University in 2005. Currently working as assistant professor in NIT Nagaland from October 7th, 2013. And he has a lot of expertise, including industry experience related to, he worked as technology consultant at Hewlett Packard for around a period of 2 years and 10 months. And he worked as a project leader at Tech Mahindra R&D for 2 years and 3 months. And he has 7 research scholars under his guidance. And he has a patent, and the title of the innovation is water distribution and management system using IoT in smart cities. And Dr. Nagaraju sir has 7 article publications in international journals and 12 article publications in international conferences and 7 research articles under communication. And he has given he was a keynote speaker in international conference on the role of data science in science, technology, engineering, management, education, and medicine at Koner Lakshmi University, Vijayawada, Andhra Pradesh, and he occupied he occupied honorary chairs, session chairs in many international conferences, and he was invited for talks in various workshops, around 15 different workshops and webinars, short-term training programs, around 48 during Corona period and post-pandemic period. And Dr. Nagaraju Baideti sir, he worked as Deputy Registrar, Academic, National Institute of Technology from 1st November 2013 to August 2017, taking care of complete activities of controller of examinations. This is about our today's resource person, Dr. Nagaraju Baideti. Sir, we are happy to have you for this session, sir. Thank you very much for your presence, and I'll hand over the session to you, sir, Dr. Nagaraj, sir.
Thank you, sir. Thank you for your warm introduction. Am I audible?
Yes, sir.
Okay. So I'm very much pleased and honored to represent the Department of Computer Science and Engineering, National Institute of Technology, Nagaland, and I'm very much happy to be part of this particular FDP. And my topics today are going to cover some basic things only, even though the ATAL FDP program theme is on generative AI. The topics given to me are, I think, very basic in nature, which is also very fundamental for learning any advanced topics. I would like to know, before I start my session, I would like to know whether all the faculty are from computer science background or there are some faculty from multidisciplinary areas.
Multidisciplinary, sir.
Okay. So that's good to hear, sir, so that I will understand from now. Before I start my session, I would like to tell one more thing to the participants. Just in case if you have any doubt which you are unable to understand what I am speaking, you can kindly unmute and you can stop me at any point of time. Or in case if you have any doubts, yeah, in case if you have any doubts, which we can take it in the further session, at the end of the session, that also is possible. One small request, I understand it is an online session, everybody will be busy at their home. So I request everybody to kindly mute your audio and video so that there is no disturbance for anyone who is actually participating to learn something, right? I know some of you might just keep it and practically not available here, but it is fine. So let's move on to the session. I will share my entire screen. And somebody please confirm whether you are able to. Today I am not only going to explain the topic, I am also going to show you practical implementation by using at least one algorithm, if not all algorithms, because we don't have that much time. So I have two back-to-back sessions. The first session I will be discussing about a simple example with k nearest neighbors algorithm. Then I will also take a data set, a real-time data set, to explain multi-class classification. And then in my next session, I will cover multi-label classification also by using KNN algorithm. Today morning also, I went to an agricultural university to explain the concepts of AI and ML with respect to the field of agriculture. So there also, I just gave a small introduction, which I would like to give here. Before I start my presentation, I would like to hear from you. What do you feel about machine learning? What is machine learning? Let's be very interactive.
So training the computer with a predefined set of data.
Okay. Training the system with the data, right? Why do we train?
Sir, with the past experience or past obtained output, we can predict the after analyzing the given input, we can predict what is the expected output.
Okay.
For that,
Anybody else? Yeah. Thank you, sir. Anybody else? Anybody else? Let's be more interactive. Anybody else? Okay. So now let's move on to understand. Right now, the field of engineering has drastically evolved in such a way. You mention any field, people talk about the applications of machine learning in that particular field. You talk about chemistry, you talk about physics, you talk about any technical engineering dimension, you talk about management. Everywhere people say application of machine learning is there. So in this particular era in the decade, you can observe everybody talks about machine learning, whether they will know about what is happening inside or not. We talk about machine learning. For example, if you talk about power systems, you talk about control system, you talk about any structural engineering, you talk about design and manufacturing, means from the circuit branch to the core engineering branches to the science, commerce, education, medicine, management, every sector, people talk about data. As one of the participant faculty said, rightly said, that we train the data or we train the model with the data to predict something, right? Now, let me put in this way. Let's try to understand. Machine learning is all about trying to mimic the behavior of the system, trying to mimic the behavior of a human being through a system or by a system. Now, when I say mimic, let us take a very simple example, right? In childhood, we are trying to ride or learn riding a bicycle. So what we do? Somebody will catch hold of us from the back side. Then they will say, this is the brake, front brake, don't apply with force. Slowly you have to apply front brake. Then this is the pedal. We feel very heavy. The cycle in our childhood, before we learn, it feels very heavy. But once you are used to riding the bicycle, you don't feel the cycle is heavy because you are not going to carry. But initially what we do, instead of cycle tire carrying us, we carry the cycle on our body because we don't know how to balance, right? Now, initially, we will hold the hands. Slowly, we start riding the bicycle. At one day, you might have noticed your father or brother or uncle, suddenly they will remove the hand from the cycle. You will go for some distance, then your human brain will say whether the person is holding or not. You turn back and see, you will notice and immediately you will fall down. Have you noticed this in your childhood? You believe that somebody is holding and then you ride the bicycle. There is another group of people. They are very hard in nature. They don't take anybody's help. They themselves will start, they will fall down, they will rise, they will fall down, they will rise, and they will learn by themselves. I'll take one more example. Imagine you are going to a new place. Nowadays, Google Map is there. Navigation is so advanced in nature. You just go to any place, you open your navigation pane, Google Map or any other map, you go whatever map says. Suddenly you changed the line. Dynamically, the map will reroute and it will show you the new route. But imagine in my childhood and all, I don't have any Google Map. So if you are going to a new place, what do? You will carefully go ask somebody, sir, I want to go to this address, sir, how to go? They will say, sir, go straight, take left and second left. Oh, it will be confusing, sir. You do one thing, go to that junction and ask someone. Then again, you go to the junction. Again, you take multiple hops and then finally you reach your destination. But in the course of that time, you will notice what is there, where you are taking left, where you are taking right. Now, second day, you have some intelligence already recorded in your brain. You follow the path. First day, you will take a lot of time to reach the destination. I'm not talking about the traffic, speed breaker, etc. In general. Second day, you will reach better than first day. But after 1 year, imagine you are daily going to the same route. If there is a pothole, even if you are talking in a phone, you will escape the pothole and go. You automatically apply the brake when there is a speed breaker because you are so used to that route. You are well equipped where you have to take, many times we do this. Some people talk in the phone, but they will reach the destination perfectly on time. Why? Because your brain has registered all the data points in such a way it has the data where you have to apply brake, where is the traffic jam, where you can skip the traffic, which route you can go. Are you able to understand what I'm saying?
Yes, sir.
So
Clearly, sir.
what is happening here? What is happening here? Learning. Who is learning? Human being. How he is learning? Two ways. One, with the help of someone or by himself or herself. Is it clear? So what I mean to say is, human being learns from his experience. How experience will come? Experience will come with processing the traffic signals, road condition, left turn, right turn. All these things are processed in our brain. So machine learning is exactly the same what we saw in the real-time examples. Now in machine learning, what happens is machine should learn by itself. Human being is learning. Now human being learns in two basic ways, one with help of someone, one without help of someone. Similarly, machine learning also has two major categories. One with the help, another one without any help. What is with help? Who will help here? Human being will not help. Now, how human being is getting help in the previous examples or use case or case studies? From the natural scenario, your eyes are actually observing, you are reading the signboard, sign signals, brain has processed and it has stored it. Brain is a supercomputer, it works very fast. But in machine learning, how model will learn? Model will learn from the data. What is data? It can be varied based on the application. For example, you are actually going for sentiment analysis. One example I am telling. What is sentiment analysis? Suppose in a Facebook, I keep on posting, I am feeling bad, I am feeling very sick, I don't like what is happening in my life. Many people will not share to any friend. Nowadays, people share in Facebook. So we can extract the text, get the sentiment polarity, and then identify the emotion inside the text. So here what is data? The textual post is the data. Some people will put video, many times. It's a very negative example, but I want to say many people commit suicide, but just before the suicide, they will put all their problems in the social media rather than sharing to someone who is caring for them because they felt alone. Why I am saying this is one of my scholar works on this area. He is submitting his thesis next month. So what is data here? The data can be image and video. Now, some people will work on recommendation systems like travel blogs. You can take the data from different travel blogs and you can recommend which place to visit, what is the time to visit, what are the hotels to be stayed or the preferred hotels, what are the budget hotels, what are luxury hotels, which area you have to go and cover. Day one, what is bad? If you type something, everything will come. How it is coming? It's all because even you go to Amazon, you log into Amazon, you will get recommended products. You log into YouTube, you will get recommended videos. You log into Hotstar or Netflix, you will get recommended videos. Based on what? Your login recommended videos are not same as me. Why? Because my watch history is different than your watch history. So, as one of the faculty rightly said, we take the data, train the model, and predict something. Machine learning is exactly the same. You need the machine to mimic the human behavior with some model. But how machine will learn? It learns with experience. How it will get experience? It gets experience with the data help and without the data help. Like somebody is helping us in bicycle. So with this short introduction, I will open my, I think now I am sharing my, I have opened one PDF. I hope everybody is able to see that.
Yes, sir.
Okay, thank you. Now, what is machine learning? As I said, a computer program. In a simple way, I will break this big paragraph into simple program. A computer is going to learn some experience E. For what? It will gain experience with respect to a specific task T. Now, when you have a task T, it will learn some and get some experience E, and that experience should be measured with some metric called as a P. What is measured? For example, accuracy, precision, so on and so forth. Then, if the performance is improved with the experience, if the performance is improved with the experience, then we will say machine learning is happening. You heard it right. Suppose you know, some cases you ask for 5-year experience guy. Why? Because the assignment that a fresher will handle is different from the assignment an experienced guy will handle. Similarly, a machine learning algorithm is set to gain experience when it is giving a better result. Is it clear? So what machine learning will do? What can it do? It can do many things. For example, you know, in your Gmail or any email, you have spam emails also and non-spam emails also. This is one of the best example of machine learning classification problem. What is classification? I will explain you very soon. So here the machine, once you click some email as spam, all the related emails for the next instance onwards will automatically go to spam email. I think you might have noticed it. So this is one example of machine learning, right? Now, there are two kinds of machine learnings. One, supervised learning. What is supervised learning? It is similar to the person who is learning a bicycle with the help of somebody. Here, in learning, supervised learning happens with the data. There is a help from the data itself. Sir, how data will help? Will data speak? Data will not speak directly, but one of the column in the data will help the machine to understand the significance of the other columns. So that particular data is called as labeled data. I will tell one example. The weather is very, very hot outside and it is having bright sunshine. The temperature is 40 degrees Celsius. So these three are independent variables. But based on these three, there is one more column called as yes, you can play, no, you cannot play. So there are some records with some 4 columns. So the first 3 columns, you will say they are independent variables. Why? Because my temperature varies, my weather report, my weather forecast can vary, but based on the weather forecast and temperature, whether I should allow the children to play outside in the outdoor or not is based on those first 2 or 3 columns. Then such kind of data or data set we say is called as labeled data set. When you say labeled data set, and if it is a machine learning algorithm, then that learning is called as supervised learning. So what is supervised learning? Inside the data, we have one column which will help the machine to understand the problem which we are going to target. Now, coming to the machine supervised learning is again having 2 categories. I will come to unsupervised learning later on. Today I am going to cover only supervised learning in a detailed manner because everything cannot be covered. There is another one called as unsupervised learning. I will show you the data set and the difference. Unsupervised learning, you will have data, but you will not have the labeled column, the target variable, which will help the machine to get the help from the data itself. So unsupervised learning is a true sense of artificial intelligence where the system will learn by itself without anybody's help. This is like learning a bicycle without taking any help from the elder. Is this clear? The difference between supervised learning and unsupervised learning?
Yes, sir.
Okay. So let me just show you how a supervised learning data set looks like, how labeled data set looks like. I'm opening a small data set here. Now I hope you are able to see the Excel sheet.
Sir, visible, sir.
Yeah, I will come to this in detail. There are 4 different features. This is some flowers data set, which is a very common one, iris flower. And based on the sepal length width, petal length width, the species is defined as iris setosa. Suppose you come to the end, you can see there are some more values, it is virginica, and there are some more values, iris versicolor. What I mean to say, there are features, for example, the first 4 features, they are independent variables. They are not dependent on each other. But based on these 4 values, you have a species that is labeled column, target variable, response variable, etc. So data set looks like this. Data set looks like this. Now let's go to unsupervised algorithm also. Just to show you, just a minute, I'm just opening and showing you an idea of just a second, guys. Sorry, I took time. Now I will show you. Let's see another data set. Okay. And you will understand the difference between the data set which is used for supervised and this is unsupervised learning. Here you have number of years of experience and you have salary. Okay. There is no help or labeled data here. For example, you observe the first record. Somebody has 1.1 year experience. Their salary is 39,000. But there is another person, 1.5, but less salary than the experienced guy. You are you able to understand? Sometimes less experience has more salary. Sometimes more experience has less salary. And sometimes more experience, more salary. Are you able to understand what I'm saying? Here, there is no standard help from the data set itself, which experience will get how much salary. Now, such kind of data set, if it exists, and if the machine has to learn, then this comes under unsupervised learning. I hope I am clear. Now, in supervised learning, there are again 2 categories. One, classification, another, regression. What is classification? Very simple. If the data is categorical data, then what is a categorical data here? For example, what is a color? Green, blue, yellow, category. How is the weather outside? Very sunny, overcast, category. What is the mood of a person? He is angry, he is happy, he is very sad, he is not having any expression, neutral expression. That is categorical data. For example, a mail is a good non-spam mail or if it is a junk mail category. Then what is non-categorical data? Numerical values. If it is non-numerical, it is called as categorical data. If the data is non-numerical, then the problem what we are going to solve is called as classification problem. Now, Coming to the numerical values, then the problem with numerical values is called as regression. For example, house price prediction, stock price prediction, height and weight prediction. These are all numbers. So simple. You play with numbers, it's a regression problem. You play with that is non-numerical data called as categorical data. We say it as a classification. For example, you give set of images of cat and dog and you give a new image and the machine is going to identify the new image is a cat or a dog. It is called as a classification problem. Is it clear?
Yes, sir.
Okay. Now, let's talk about classification problem. Now, when you talk about classification, it's something like yes or no or 0 or 1. If the classification has only 2 classes, it can have more than 2 also. Either it can be yes or no sometimes, or it can have multiple classes also. If it is having only 2 possible classes, then it is called as binary classification problem. For example, you are from a EEE department. You are reading the vibration of a machine. In a machine there are vibrations, so you are reading the vibrations. Based on the vibrations, you are going to identify whether the machine is going to be faulty or not. Either faulty or non-faulty. Only 2 possible outcomes. Then you will say this problem is machine learning binary classification problem. For example, you are going to work on a smart grid power distribution and you want to identify whether somebody is actually taking the power illegally. So power theft happened or not? Yes, happened, or no, it did not happen. Got it? What I am saying? So this is also a binary classification problem. Okay. Now, suppose if it has more than 2, then it is called as multi-class classification. That I will tell in the next session. Now let us consider a binary classification problem, right? Mathematically, any classification algorithm will have an output function termed as y when it is mapped with an input variable termed as x. For example, y is equal to f of x, where y is the categorical output. Y is the categorical output. What is x? X is the input variable. Then what is f? F is the function. F can be a model. F can be a model. It can be k-nearest neighbor algorithm. It can be SVM. It can be naive based. It can be even multiple of multiple methods where we say ensemble techniques. So what I mean to say, mathematically, we can say y is equal to f of x. Y equal to f of x, where y is the outcome, x is the input. Then, for example, if the possible outcome is only 2, as I said earlier, then it is considered as a binary classification problem. Now you can see here, for example, there are 2 classes. 2 different data points are there. One with the shape of a triangle, one with the shape of a circle. Now you can say by just visualizing it, right? You can say class A is the circle data points, class B are the triangle data points, right? So this is one example of binary classification problem. Okay. So as I said, there is another possibility which will have my session will over. Okay. So I have the key. Binary classification is only possible too, but in my next session, I will also explain multi-class and multi-label where there is a possibility of having more than one class. Then there are two again different types of learning mechanisms. One, lazy learner. Another one is maybe rapid learner or eager learner. Now, what is a lazy learner? Lazy learner will take the training. I will also explain what is training data set and what is test data set. Very simple. You will take the data set. Imagine 1,000 records are there. Very example. 1,000 records are there. So first you will feed the data to the model. Then it will take the data, process it with the model, and it will gain experience. Usually we may take 70-30 or 80-20 split. More training data, then more experience the machine will learn. The more the data you give with the training data set, the learning is also proportionate to the amount of training data you are giving. Then you take some portion of test data, then you will test the model whether the model is coming correct or not. Very soon I am going to show you practically also with Python coding, live coding examples I will show you. So in lazy learner, what happens is it will store the training data set and it will wait till the test data set is also given. So for example, KNN algorithm is a lazy learner. Okay, then we will see in detail what is KNN. There is another learning type typically called as eager learner. What it will do, it will take more time for training and it will take less time in prediction. So for example, decision trees, naive Bayes, artificial neural networks, etc. Right? Then some amount of theory I have to cover so that we can understand the practical knowledge also. Now, different types of classification algorithms. As you know, the difference between linear and nonlinear model. So linear models, you have logic regression and SVM. In nonlinear model, you have KNN, naive Bayes, decision tree, kernel SVM, random forest. We are not going to cover everything, but at least KNN I am going to cover. Now let's just take a couple of minutes short break because I am continuously talking. I just give a 2-minute hold here. We will continue. If you have any doubts still here, you can ask me. You are able to understand the flow I am explaining. Is it clear or any confusion is there? You please let me know.
அப்புறம் இது சண்டே ஒரு நாள் போகும் சார் வர சண்டே நீ அது கொஞ்சம் தெரியல நான் சொல்லி ஐடியா சொல்லிட்டேன் சரி இந்த மாதிரி ஆப்ரேட்டர் அனுப்பிச்சிருக்காங்க நேரம் வச்சு இருக்காங்க சார் பார்த்துட்டீங்க நேரம் வச்சு இது ஆஃபர் வாங்கிட்டு சார் நீங்க சொல்லி 2 நாள் போட்டுரு ஓகேவா திரும்ப அங்க போய் ஆஃபர் வாங்கிட்டு சார் இங்க
உங்க சிஸ்டம்ல அன்மியூட் ஆயிட்டு இருக்கு சார் ப்ளீஸ் மியூட் யுவர் ஆடியோ
ஒரு 2 நாள் போட்டுரு
சார் ஆடியோ மியூட் பண்ணுங்க ஓகே I request the coordinator to mute their audio please. Sundararajan sir உங்க ஆடியோ அன்மியூட் ஆயிட்டு இருக்கு ரைட் so let's continue participants, let's continue and thank you in the chat messages. I am getting positive response, that's good. Right, now let's go and try to understand what is k nearest neighbor algorithm in machine learning doing for classification problem. Okay, so here it is a very basic and easily understandable approach. This works based on the distance between the data points. Basically, in a simple terminology, see, I don't teach with a lot of definitions, because if you can understand the concept easily, you can really read the definitions and you can remember. So I always believe in understanding the concept rather than mugging up the definitions. In k nearest, it is also called as proximity based algorithm. Proximity based means distance based. What is distance here? Distance between the data points. For example, you take some data points, you brought one more new data point, and you want to know this new data point belongs to which kind of group. Then we calculate the distance, and whichever getting the maximum, we will say this belongs to some class. So as simple as that. So what is k nearest and k nearest neighbor algorithm? Here k is an integer value. Here k is a integer value. For example, sir, what kind of integer it is? It's a positive integer, and it's not a it should not be 0. I will tell you the details about how to select k very soon. So here you take, for example, 5 as k. That means 5 nearest neighbors distance will be calculated. Basically, distance will be calculated between one point to all other point. One point to the new point to all other points. But which is the 5 nearest neighbor, that will get the classification into that particular category. Right? Now, I will show you a theory we can skip. Now, let's try to understand here. There is one data point which I have highlighted in blue color. Now you want to identify whether this new data point belongs to category A or category B. Then how KNN will work? KNN will work in this way. Very simple. First select the number K. How to select, I will tell you. Then calculate the distance between the data point, which, for example, here the blue color data point. You will calculate the distance between this. You will calculate the distance between like this. You will calculate the distance for this, and then whichever is coming nearby, whichever gets the majority, that will be the outcome of a category. Now, there are so many distance metrics. I think everybody knows what is an Euclidean distance. There are other Manhattan distance, Hamilton distance. There are several distance metrics that you can follow. But by default, the distance metric is in general Euclidean distance. Now, so you select the number k, then you calculate the distance. Then among these data points, you select the nearest k neighbors. Whichever is getting the maximum, that will be the category. It's as simple as that. Okay. For example, you see here, we have a new data point. Now I want to know whether which category this belongs to. Imagine, just imagine as of now, k is 5. Imagine k is 5. So what I will do, I will calculate the distance between that new data point to all other data points, right? For example, you see, I think everybody knows about the Euclidean distance formula, root of x2 minus x1 square plus y2 minus, here x1, y1 are the coordinates of one data point which you want to take, and the other data point is x2, y2. Now you calculate the distance. Imagine a scenario like this. 2 blue color category B are near to it. 3 green color data points are near to it. So 3 is the majority. Category A. will be the new data points category. Like this we will do. Any doubts here? Now, the question is, how do I select the K value? How do I select the K value? We can select the K value. We can select the K value randomly. There is no mathematical model to define the K value. Okay. So how do I select them? Usually what we do is, in general, you should not take even number as K. Sir, why I should not take even number? Very simple. In cricket, every time if there is a ODI series or anything, usually they say 3-match series, 5-match series. In test only they will say 1 or 2, because test there is every possibility of match also. So what I am saying is, odd number is only the tiebreakers. For example, you take K equal to 4. 2 points are near to category A, 2 points are near to category B. Then where I will categorize which class? Suppose if there are odd number, then there is always a tiebreaker. Is it clear? In general, K is not even. Then K should be small value, very small, like 1, 2, like that. Why? Why? Because if you take 1, it leads to more noise. Why? Because everywhere, for example, you will get everything you will get. Means from this category also you will get one nearest neighbor, the other category also you will get nearest neighbor, one more category is there, you will get nearest neighbor. Then how you will choose? So what we do in research work is, we take different values of K, analyze the accuracy or any other performance metric, and then we choose the best of the values by trial and error basis. Is it clear? Is it clear?
Yes, sir.
Okay. Now let's see a typical case. Imagine you have taken K equal to 3. Imagine you have taken K equal to 3. Now I highlighted in the PDF. When you take K equal to 3, one star point is there, which is class A. 2 triangle points are there, which is class B. Now our machine learning algorithm will say the yellow question mark data point belongs to class B. But what will happen if I say K equal to 7? Same data point, K value differed. Now you see, if K is equal to 7, 3 data points of triangle are coming, but 4 star points are coming. So there is every possibility, based on the K, your category may change. So that's why we go with the trial and error basis and select the best K value. But there is no formula available to select the K value. Okay. So how do we select? As I said, there is no predefined statistical methods. So you will take random K. You should not take a small value because decision will be unstable. You should not take so much big values also. And you go with the minimum K value, the optimum K value, which gives the minimum error rate. Sir, what is error? Error is nothing but how much you are deviating from the actual value. You have some data, right? And you know the data point also. I am talking about supervised learning. Then you test it, then check whether it is the actual value is equal to the predicted value or not. Okay. Now, let's come and try to learn some practical concepts here. Right. Now, I am opening a program. I will explain every line. I will explain every line with a simple example. Now I am going to take a very simple example. Then later we will go to a complex example. Okay. So I love to explain via coding. So Don't worry about the number of lines and all, right? Let's go to the PDF also. You can see here, we have a Python library called as Scientific Kit Learn Library. In shortcut, it is SCIKIT Scikit Learn Library. What Scikit Learn Library offers is, Scikit Learn Library has so many models of machine learning developed inside it. So we can make use of Scientific Kit Learn Library, and we can actually learn, or we can actually work with several machine learning models. So, sir, how to install this, where it is available? It is very simple. You have to just type pip install Scientific Kit Learn. Scikit Learn. This is the, right now I have already installed it. So it will say requirement already satisfied. But in case if you want to install, this is the way you have to install. pip install. Now, every line I will explain. If you are not understanding, please let me know. A simple example I am taking. Okay. The first one in Python, I took a list. Line number 3. I am taking some different combinations. The weather forecast, sunny, overcast, rainy, different values I took. A simple list. You can see line number 3 is a simple list. Then line number 5. I am taking another list called as temperature. Hot, mild, cool. This is the combination. So you have 3 unique values in weather: sunny, overcast, rainy. In temperature, you again have 3 different values, that is hot, mild, and cool. These are 2 different lists. Now I am taking one more list. Consider this is the target variable. Ideally, weather is one feature, temperature is one feature. Now you see the first value in weather, sunny, first value in temperature, hot. Outside it is very hot and sunny. Play. No, that means do not play. So in the data itself, play is the target variable. So this is very much applicable to supervised learning. Is it clear? I have taken 3: weather, temperature as input variables, independent variables, and then I am taking one more, that is the target variable. Is it clear? Is it clear?
Yes, sir.
Sir,
Okay.
yes.
Yeah. Now, when you install sklearn, you can see here, when I tried installing, it said requirement satisfied, because I have already installed it. Now, sir, where do I get this? Let me open the, say, as a faculty, when you are learning something, we should learn in a way where we will explain the students in the better manner where they will understand. Now, I am still using a old version because I don't want to update and get into trouble. So this is my Python home. But for you, maybe you will install in a different directory. Then you will go to Python home. Inside Python home, there is a library directory. Inside this, there is something called as site packages. Every library which is installed in Python will go to this particular directory. So here, for scikit-learn, when you install, it will come as a subdirectory sklearn. So This is the place where my sklearn is installed. Sir, how I know? You can clearly see scikit-learn is installed here. That's exactly what I have opened in another command prompt. Now, if you just list there are so many things which will come. Okay, few things I will also explain. Okay, I cannot explain the entire library, but one or two I will explain. Now, let us try to understand line number 9. Let us try to understand line number 9. From sklearn.preprocessing, import label encoder. What is this? sklearn is the package. Then what is dot? If there is sub package, let's go and see. Now you can see there is a sub package called preprocessing. Inside this, we are trying to import label encoder. Now I will ask the participants in line number 11. I highlighted something. Label encoder, open parenthesis, close parenthesis, dot. What is this label encoder according to you? With a programming perspective.
It is a function.
It is a function. Okay.
So it's basically
Anybody
used
else?
to convert to numerical values.
No,
Because scaling
yeah,
works only on numerical
no.
values.
Ma'am, I didn't label encoder does. I just told when it is written like this in a program, what exactly is this? Somebody said it is a function.
Yes, it is a function.
That's what I am expecting. Not what label encoder does. Okay, this is not a function. This is not a function. It is not a method. This is the place where I'm sorry to say I'm not pointing to this particular group of faculty. In general, faculty is not getting clarity between a method and a class. Why? Because of late, I'm very sorry, I'm very frankly telling, I'm not pointing to anybody. We don't write any coding. We only tell theory, right? That's why this label encoder is not a function. It is not even a method. It is basically a class. There is a difference between a class and a function. There is a difference between a class and a method. Fit underscore transform is a method, but label encoder is a class. Sir, how can you say it is a class? So what we have to do? We should do Python postmortem, not the real Python snake postmortem, whereas we should do the postmortem in this way. Where is it available? Inside sklearn preprocessing. Now when I say it is available, so I have to open and see. But if I open and see here, I don't understand where exactly it is there. There are so many Python files here. Any time, remember, you want to understand any library, go inside that library and open the init file, which is the beginning of any package's execution. So I opened the init file. Now inside the init file, you will be able to understand what you are searching. So what I am searching? Label encoder. Correct? No. What I am searching? I want to search what is label encoder does, or what exactly is label encoder, right? So I open the init file, then I have to search where exactly it is there. See here in line number 32, import label encoder. From where? From dot underscore label. That means label encoder is available inside another file. Dot means current directory. And I think you know about dunder methods, single underscore, double underscore, as we are not teaching Python here. So I'm not stressing too much, but we have to search whether underscore label.py is available or not. Yes, it is available. What is dot here? Dot means current directory. Yes, it is there. Now we have to open that. See, Python hides so many things. So that's why many people say Python is easy, sir. Python is not easy, or C language is not difficult. You should open and see what exactly is there. Now here, there are so many things, but what we are looking for? We are looking for label encoder. What is label encoder? Clearly it is written, it is a class. So just because there are parentheses, you should not think it is a function or a method, right? Because class will have constructors. Constructor can be called as a method only, right? So label encoder is a class. Label encoder is a class. Okay. Now, when we tell this is a class, what it does? Now let us see what it does. Label encoding is one pre-processing technique where for categorical value, you will get some encoded numerical values. Because this class is not about the entire pre-processing, so simply I am explaining. For example, you have sunny, overcast, and rainy. Alphabetical order you have to do. What label encoder does is it will take an alphabetical order. In alphabetical order, what happens? Which alphabet will come? M, N, O, P, Q, R, S. So M, N, O, overcast will come first. Then overcast will be getting a label 0. M, N, O, P, Q, R. R will come next. Rainy, R will be 1. Sunny comes last. Sunny will be 2. So what is label encoding? Label encoding is converting the categorical value to the numerical value. Then you will get a doubt. Why should I convert? Why? Because many machine learning algorithms expect the data in numerical values. But you have categorical data. What do? You pre-process it. Label encoder, one-hot encoding. There are many techniques. So here I am using label encoder. I am using label encoder. So let's go to the code now. So if you want to learn more about it, I showed you how to go inside and see which is a class, which is a method, what are the arguments that will go, what are the default values, everything you can go inside the predefined library files and you can see. Now, inside label encoder, there is a method called as fit transform. What it will do? It will fit and transform the categorical data into equivalent numerical values. Is it clear? Line number 11, is it clear? Let's continue. Similarly, now what will be the outcome? Encoded weather. Weather is sunny, overcast and rainy. Then you will get combinations of 0, 1, 2. Similarly, what I am doing is for temperature also I am using the label encoder. Then here also for temperature I will get some values. Then whether to play or not, that also I am using the same encoder. So finally what I did is I have taken the category values and changed it to numerical values. Now this is a small example, right? Here weather is a list, temperature is a list. They are completely two different lists. It is not a data set here. So what I am going to do is I am bringing the combination SUNNY Sunny and HOT hot together. Second instance, sunny and hot together as a tuple. Then overcast and hot, rainy and mild. I want to pack them in a tuple. How I am going to pack? Here in line number 23. Jet IP zip will pack the values into a tuple. So what this will do, it will take the first value from the encoded weather, first value from the encoded temperature, it will pack as a tuple. All the tuples I am converting into a list. Finally, I will show you in the PDF itself what outcome will come. Clearly you can see sunny got value 2, again sunny 2, overcast 0, rainy 1. This is encoded weather. Similarly, encoded temperature. After that, what I am doing, I am combining the features. Clearly you see, first value in encoded weather is 2, first value is encoded temperature is 1. Now you see 2 and 1 is one combination. Okay, and based on the combination 2 and 1, if the combination is 2 and 1, basically sunny and 1 is hot. Play is 0, do not play. Now you see the next combination, third combination, 0 and 1. What is 0? Overcast. It is overcast and it is hot. Yes, you can play. So basically what we got is, we got the input features and the outcome variable. This is about data. Now what we have to do? We need to implement k nearest neighbors binary classification. So let us see line number 28. Let us see line number 28. Now in line number 28 we have from sklearn dot from sklearn dot neighbors import k neighbors classifier. Now again what we have to do, if you really want to know, right, you have to go to the site packages. Inside sklearn there is neighbors. Yes, it is there. It comes with practice. Again list the values. I don't know where it is written. What I have to do, simply go to the init file. I am going to the init file. Now you see where it is available. It is available here in line number 12 from dot. Dot means current directory, underscore classification. That means you have to go and see whether underscore classification is there or not. Yes, it is there. Go here. Now you have to see, yes, there is a class called as k neighbors classifier. So this is also not a method. Just because there are parentheses, you should not get confused and confuse the students. Right? Now, what it will do, as I said, you see here, default k value is 5. If you want to change, you can also change. Okay, it will calculate the distance. Everything is written. There are so many concepts here. You can also go and you can see. Here you see how the distance metric is happening, how pairwise distance is calculated. Everything is written here. Okay. Let's continue. I hope I am visible to you. There is some power problem here. Anyways, now let's go to the code. You see how simple it is. You are defining the model, my model, or x equal to y equal to, my model equal to k neighbors. You are just defining the class. You are actually instantiating. You are actually calling the class. That means you are creating an object of that class. The moment you call the class itself, basically an object will be created. Okay. Now, with that object, here you are saying n underscore neighbors equal to 3. You don't send here. you don't set any argument here. By default, instead of 3, 5 will go. But here I am exclusively mentioning 3, so my neighbors will be 3. Then see here, my model dot fit the features. What are features? It is coming from line number 23. What is line number 23? The combination of weather and temperature values are my features. So I am sending the features, and then I am also sending the encoded label play. What is encoded label play? That either play or not, 0 or 1. Now here learning happens. Here line number 33, learning happens. Now once learning happens, I need to predict the outcome. So what I am sending here, you see, my model dot predict. Here predict is a method. Fit is a method. Fit is a method which can be called from the object of class K neighbors classifier. Predict is also a method which can be called from the object of class K neighbors classifier. So here what is happening? I am sending some different values of features. For example, 0, what is 0, 2 here? 0 means overcast. Sorry, sun, MNOP, yeah, MNO, correct. Overcast. And 2, cool come first, hot comes next, mild comes 2. That means it is cool and mild. Whether I can play or not, we will see in the outcome. So 3 different combinations I am sending. You can see the predicted output also. For example, in the PDF, this is the execution. So it says in the first feature which you are sending as 0, 2, it says yes, you can play. That is also true, right? Now how to know whether the predicted outcome is correct or not? For that we can have classification report. For that we can have a classification report, which I will tell you. Let me give a small gap here. Again, a 2 minutes break, so that you will digest what I said and you will ask me if you have any doubts. So let me execute the program and show you in the live what is the outcome. Now you can see the outcome also, right? Yeah. Any doubts here? You please ask me. In case if you have any doubt, at this point of time, if you have any doubt, you can ask me. I stopped my session here. Now the 15 minutes, it is a question and answers, and then we'll take a 5 minutes break because it is a back-to-back 3-hour session. So I also understand the difficulty in online. So I stop here. If you have any doubts, I will clarify the doubts in this session. Then we will continue with the other topic with multi-class classification and multi-label classification by using KNN classifier. So if you have any doubts or if you want to give any valuable feedback, you can also give me so that I can revamp the way I am explaining. If it is okay, it is fine. If you want a different kind of explanation, I have to adapt to it in the next session. Yeah, up to the organizers now. I am done with my first session. Any question and answers you have, you can please ask. So no questions being asked. So I think we will meet again at 7:30, right? For the next session. Over to the organizers.
Okay, sir. Okay, sir.
Participants, shall we start the next session or shall I wait for some time?
Sir, you can start, sir.
Thank you, sir.
Sir.
So we are done with the basics of ML. Then we saw one example where a simple example of binary classification. The data set is very miniature version data set only with few values. Now let us try to understand multi-class classification problem with a real-time data set. And I will explain the concept with the coding together. So let's see that. What is multi-class classification? That we need to understand. If the outcome is only two classes, then we say it is binary. And if it is more than two, it's as simple as that. We say it as multi-class classification. For example, if I give you the images of cat and a dog, train the model, and if I give a new picture, you are going to say whether it is a cat or a dog, then it's binary. Then what will happen if I give 3 animals data set and then ask you classify this, then it becomes multi-class classification. It will become multi-class classification. Is this clear? Then 2 class categories are there, then it is multi-class. Now, in addition with scikit-learn, I am going to also use pandas library, which is basically used for data analysis and data handling. I may not be able to explain everything in pandas package now, but I will try to explain few methods which are available where we are going to use the pandas dataset to read the dataset or handle the values inside the dataset.
Dear participants, please wait for some time as resource person is having some technical issue. Thank you.
Okay, ma'am.
Faculty, am I audible now?
Yes, sir.
But
Yes,
I'm
sir.
extremely sorry. I don't know.
Yes, sir.
It got disconnected
Yes,
by
sir.
default.
It's audible.
Okay, thank you. Let me share my screen and chalo. Now, as I said earlier, we are going to learn some more libraries like Seaborn and Matplotlib for data visualization, right? And whenever there is a requirement, I will talk about data visualization when I am explaining the case study. Now, the data set, what we are going to, this is taken from internet only, the data set is iris flower data set. As I already showed you in the first session with respect to the supervised and unsupervised learning, the iris flower data set consists of 4 different features with 150 data points, 50 for one species. So 350s are 150. Now this particular thing is also available in internet in many places, even from the Kaggle open source also it is available. So this is the images of, these are the images of the 3 flowers. You can see 3 different species of iris flowers. One is Setosa, versicolor and virginica. So you have petal and sepal, length and width. So petal length, petal width, sepal length, sepal width. So you have 4 features. You have 3 unique things. Now, when you give some values of petal and sepal length and weight, your algorithm should be able to classify whether it is belonging to Setosa or versicolor or virginica. So because there are 3 different outcomes, this comes under multi-class classifier or multi-class problem. Another example I will tell. You are trying to understand the emotion of a person, whether he is feeling good or bad, then it is binary class. But a person can be surprising, a person can be joyful, he can be sad, he can be neutral. If there are multiple emotions more than 2, then we say multi-class. So for that, let us see the code. I will explain each and every line in the code. Don't worry about the length of the program. It is very, very simple. Let us see the first line. This is already known to you in the previous session. We are going to use pre-processing techniques. What pre-processing we are going to use? That I will show you and teach you later when the line comes in the code. So one, we are going to import the pre-processing package in sklearn. Then second, we are going to split the data into training set and test set. Where it is available inside model selection inside sklearn. So let's go to sklearn first and see whether model selection is there. Yes, it is there. Go to model selection. One second. Sorry. So inside you have to go to init.py always. See, I am explaining as if no one knows anything. Okay, I teach like this only. Please don't feel bad. Now there is a split. Yes, there is a split. Let's open this. If you show one example like this to the student, they get more interested rather than many people run away from the code. Why? Because and people use Python, but they don't know what is happening inside. That's not right. Students should know, faculty should know, scholars should know, UG student, PG student, research scholar, faculty, everybody should know. The technical assistant should know. How it happens. Now you see, it is not a class, it is a method. So here you will see by default the shuffle is true. It will shuffle the data while it is splitting the training and testing. Random state, if it is 42, then every time the same amount of the data will go into training and testing. You can see the train size and test size. By default, it is set to none. You need to set. Usually we take 80-20 or 70-30 like that, right? So you can go and you can read more about how the split is happening between the training set and test subsets, right? Let's go back to the code. Let me close all. Fine. Now, you know this k-nearest classifier. Then we are using Python plot, which I will explain when the particular line comes. And we are also using Seaborn, right, for exploratory data analysis. And pandas for handling the data frame. What is a data frame? Data frame is a data structure in pandas package where the data is represented in a two-dimensional array. You know what is a two-dimensional array, right? Combination of rows and columns. Now, let's see the line number 9. Here, iris.csv is a dataset file. Let me show you. You can see here, the one which I have opened also earlier. So what we are doing here is using pandas package, it has a method called as read_csv. Read_csv will take the file, the dataset file, basically comma separated value. It will load into a data frame, which is nothing but a two-dimensional array. So here, if you see, I am printing the data frame dot head. So first 5 records will be printed. Sir, is it required to print? It is not required to print, just to show you how it looks like. Let me see this. These two lines have created a data frame which you can see. Is it clear? Any doubts? Then next, directly, I have taken the screenshot. Okay, my iris data frame, I am passing the species feature and then calling a method called as unique. So what it will do, from the species column, it will take the unique values and it will display. Sir, why are you displaying this? Just to show you, it has more than more than 2 categories. Is it clear? Then the most important thing in any machine learning algorithm is pre-processing. Now, pre-processing has two different concepts. One, we should not have missing values. We should not have missing values. Then somebody can say, sir, how data set will have, why data set will have missing values? How data set will have missing values? Just imagine a case. You are trying to read the data from a router and you are capturing the values. Some problem happened in the network and some values for 5 minutes you have not received. Then what will happen? There are missing values in the data set. Now, let me take another example. You are taking a survey. For example, an ABC Incorporation company is taking a survey of the customers. Their idea is, what is the income group Suddenly somebody muted my audio. Am I audible now?
Sir,
Yes,
now
sir.
it is
Yes, sir.
audible,
Yes,
sir.
sir.
Yes, sir.
Okay. Till I don't
Sir.
realize when I got muted. I don't know. Anyways, we are talking about mapping. Is it clear? We are talking about mapping the labeled data to the encoded labels. For example, Setosa has 0. Earlier we used label encoder. Now there is another way where you can send the basic column which you want to map with the method map, and I am giving this as an integer, as type integer. 0, 1, 2
Sir,
are
excuse
integers.
me, sir.
Yes,
Sir,
madam.
your screen is not visible, sir.
I am already sharing. Okay, let me stop sharing and share again.
Yes, sir.
Is it visible now?
Yes, sir.
Okay. After verifying the values, I am trying to map the numerical encoded values to the label. So I am sending the label species. I am using a different method like dot map Setosa as 0, versicolor and virginica as 1 and 2, as type integer. So the outcome is given in the PDF. I will share the PDF to Professor Kanya madam. Madam can share with all the participants. Now, another important thing is exploratory data analysis. What is exploratory data analysis? Before you give data to the model, you can actually understand some insights about the data. You can understand some insights. What kind of insights can I understand? Let's see. We can have some correlation between the features by using the Seaborn library. So here the code is written. You can see here the diagram. Background is white. It's a white grid. White color with grid. That is given here. See, this session is not about entire explanation of the code. So I have to skip few things, but I will just mention it. So the white grid style is set. Then we are going to use pair plot. Pair plot means basically you correlate each value with the other value. Then hue is species. Basically, you are taking this particular species here. Then height equal to 3. What is 3? 0, 1, 2, 3. That's the height. You can see the height. 0, 1, 2, 3. Now, my plot dot show is actually showing this. What is this? This is a white grid. What you are able to see, if you can observe properly, two different flowers are very tightly coupled, but one is little unique, but the other two are very much identical. Actually, what I am talking, let me show you by going back to the actual flowers image. Here you see, you yourself will tell Setosa is little different, but versicolor and virginica are different but little similar. Are you able to understand what I am saying? Is it clear what I said? That is visible for a human eye, but you can also get the insights from the exploratory data analysis. Here you can clearly see zero species, that is Setosa, is very unique when compared to the other two. They are very tightly coupled. Is it clear? Am I audible?
Yes.
Okay.
Sir, you are
Thank
audible.
you. Thank you. Thank you. Now,
Yes,
the
sir,
next
sir.
line is facet grid. The next one is facet grid. We are going to use some scatter plot matrix with sepal length and width. Why sepal length and width? I want to show you the outcome. Here you see, even if you use sepal length and sepal width, Setosa is very much identical. The other two are not very much identical. They are very much similar. But the task is to identify the difference between the three species. So this is one small example of before executing or before giving the data to the model, identifying some insights just for our understanding. Some features are very important, some features may not be important. How you will know? By doing some exploratory data analysis. Okay. So what we understand from this, Setosa can be easily identified. Length and width are very important to identify the identical or the unique species. Is this clear? Now, I will tell one small, very funny example on a lighter note. You know, whenever somebody is getting married, the bride and bridegroom will come with a lot of good costumes and a lot of cosmetic changes. Next day you see them, you will identify same bride and bridegroom, they look very different. Here, just imagine the boy is ugly. Just the boy is ugly, nobody will say no, somebody else will marry because the boy is ugly. We will make the boy also handsome, right? Example I am telling. Here what is happening? During the marriage, we are applying so much of filters to the person to make him or her look handsome or beautiful. Correct? Here, you are not changing the person, but you are changing the appearance. You may wonder, all of a sudden, why Nagaraju is telling all these things. Now, coming to the example, the technical aspect of it, there are some scenarios where you need to pre-process the data. What is pre-processing here? Transform the data in the way of model's expectations. For example, k nearest neighbor will expect the data to be in the range of 0 and 1. In the range of 0 and 1. But you see our data, whether is it in the 0 and 1, you see. Let me just show you. You see, it is not in the range of 0 and 1. Yeah, petal width is there. But you see the other three values? It's not there. I am only showing the first 5 values. Sometimes the values will be out of the range. So you have to bring it within the range. So there are different pre-processing techniques. And I will tell one more example. Some algorithms expect the values to be in Gaussian distribution. If it is not in the Gaussian distribution, you have to apply some mathematical formula and bring it to the nearest Gaussian distribution. Okay, that is called as standardization. Bringing to the required range of values is called as rescaling or Yeah, rescaling basically. Okay, bringing the values to the required scale is rescaling. So here I am going to use that particular rescaling. Why? Because I'm going to use KNN neighbors algorithm, K nearest neighbor, and it is expecting the values to be within the range of 0 and 1. Sometimes you have to use standardization. Sometimes you might be working on a digital data where you need a threshold and you need either 0 or 1. Then you use another technique called as binarization. Okay, there are several techniques. Like as I said, label encoding is also one pre-processing technique. So another technique which I am explaining is rescaling, right? For that, what we need to do? You see here, let me go to the code. Now, in my data set, I have 4 independent variables: petal length, petal width, sepal length, sepal width. I have one outcome variable, that is species. So here what I am going to do in line number 37 and line number 40 is, first I am considering input data. So from the data frame, I am dropping the column species. Dot drop will drop. It will not change the data frame, but rather it is again coming to x underscore data. What is x? X is the input component. Okay, input data. What is axis equal to 1 here? Axis equal to 1 will drop the column. In DROP drop, with axis as a parameter with value 1, it will drop the column. So we are not dropping the column from the data frame. I am dropping the column and saving it in x underscore data. So in line number 37, x data will have only the input variable. Then I am taking only the outcome as y underscore data. So I will get x underscore data, I have input, y underscore data, I have output. Now I am defining my scalar, rescaling the values. Min max scalar is a class that brings the values within the range given by us. This is a topic called as pre-processing. Inside pre-processing, this is called as rescaling the values. So min-max scalar is a class, and now that is my scalar in line number 43. So my scalar dot fit transform. So we are changing the input 4 features into the range of, by default the range is 0 and 1. If you want, you can also explicitly mention. So if you see my PDF, now you see here, they are completely within the range of 0 and 1. Now remember, it is not giving new values, rather it is transforming the values as per the given scale. Like bridegroom and bride will look very beautiful and handsome during the marriage, but after that they will be looking very different, right? In movies also we will see. So many people will look very beautiful and handsome, but outside if they remove the makeup, they will look very different. But person is same. Now, after that, I am calling train test split inside the model selection. What it will do, it will split the data into training set and test set. Here I gave test size as 0.2. That means 20% testing, 0.8 will be training, that is 80% training. Now, a random state, you can go and learn different things. There are different combinations. If random state is 42, every time you will get the same amount of data, same records in the training and test, because this splits in a random fashion. Now, there are 4 outcomes here. 1, X underscore train. What is it? Input training set. Y underscore train, outcome of the training set. Then X underscore test. It will give the input of the test data. Y underscore test is your outcome of the testing set. Once it is split, the rest is common. You define the classifier, you fit the model with the training set, then you predict the model with the test set. Is it clear? Any doubts here? Now,
Sir,
let me, yeah.
sir, we are doing rescaling. Is it that
Yes, ma'am.
I have to do always normalization, or I can use standardization also sometimes?
Yes, ma'am. See, normalization, basically there are two, L1 and L2, where if you want to bring the values to the sum of the squares to the unit 1, then you can go for normalization. Standardization is all about, ma'am, if the model is expecting nearest Gaussian distribution, then you have to use standardization so that it will remove the biasness and it will make sure that the values are near Gaussian distribution with a proper bell curve. Based on the requirement, you have to use.
Okay, sir. Thank you, sir.
Thank you, madam. Now, once the predicting is done, I need to see what is my accuracy or what is my performance of the model. So you need to go for the performance evaluation. So we have something called as inside sklearn metrics. There is something called as classification report. What it will do, I will show you. It will show accuracy, precision, F1 recall, right? Confusion matrix. Next one. What is confusion matrix? True positive, true negative, false positive, false negative. I think you might have heard about this. That's from there you will get the different classification reports. Okay. To get that, you have to use the metrics sub package. So if you call classification report, confusion matrix, you will get the number of values in true positive, true negative, false positive, false negative, and then classification report will give you accuracy, F1 score, support, and precision. Okay. For example, if you want to know the accuracy, that also can be done. Let me just execute this and show you the complete program. Let's take a 2 minutes pause here. I am back in 2 minutes. I'll just fill my water and come. Yeah, here you can see the white grid after the outcome of the program. You close this, you will get the facet grid. You can see. Then you can also see the confusion matrix, then the different classification report. And here you can see I am getting an accuracy of 96.67%. So this is how you can execute or implement multi-class classification problem. So any doubts here? Any doubts here?
No, sir.
Okay, thank you. Now let's go to multi-label classification. Now this is another classification problem where you may have, let's see here, just a small image. Now if I ask a question like this, whether there is a house, tree, beach, cloud, mountain and animal, your response will be, there is house, yes, there is no beach, there is no animal, yes, there is a cloud and tree, but no mountain, right? Now, I will show you one simple example and then explain you about multi-label, okay? I am not promoting any movie here, but when I prepared the notes, that time I have taken this example. There is a movie called Asuran in Tamil, acted by Dhanush. It has been remade by one more person, Venkatesh, in Telugu. I am a Telugu person, so I just put a Telugu movie here, but I am not promoting anything. You know, every movie will get a censor certificate. Universal, adult, U by A. Here you can see U by A 13 plus. What is U by A 13 plus? Under 18, above 13, kids can watch this movie along with the parent. Usually in a movie ticket, nobody will see. Even in adult movie, all violence movie also, A certificate movie also, everybody will watch. But ideally, why censor is giving this certificate? Because they want to control who has to see, who should not see the movie. Fine. So a movie censor can get U, A or U by A. So multi-class. Now, inside that multi-class, for example, you see in this movie, lot of fighting is there, lot of emotion is there. So it belongs to the genre drama and action. You know, horror comedy movies will come. It will have horror also, it will have comedy also. But everybody can see, then U certificate, and lot of violence is there, then they may give A certificate. Only adults should watch. That means in multi-class also, there is another classification where you can, for example, in music, you have pop, jazz, rock, etc., etc., right? You understand the difference between multi-class and multi-label? Is it clear? Inside a class, you can have multiple labels also. Is this clear? Is the example and the
Yes,
concept clear?
yes, sir.
Yes,
Yeah.
sir.
In such case, we have to go for multi-label classification. So I am not reading all the theory. Let me explain the multi-label KNN classifier. Now I am taking one common data set, which is a benchmark data set called as semantic evaluation. Now what is this? Let me show you the data set. Okay, if I show like directly, I will open so that it's easy to see in a Excel form. You know, just imagine this data set is all about you want to visit you are visiting a restaurant. Somebody asked you, tell me the feedback. You told it's a good restaurant. It's a feedback. Somebody will say, you know, one day I felt very hungry and my friends were very nearby. So what I did, you know, I called all my friends. No, I went to a restaurant. The ambience was very good. The spread of the buffet was too good, but it is very costly. taste is very good. See, one person told, simple, restaurant is good. Other person has narrated a big story. The other person has narrated a big story. Okay. This is the data set which talks about a response in a text form. See here. Somebody gave a feedback, but the staff was so horrible to us. That's the feedback. Suppose another person, you see, to be completely fair, the only redeeming factor was the food, which was above average, but could not make up for all other deficiency. Now, another person is saying the food is uniformly exceptional. Are you able to understand what I am saying? Okay. So this is the data set where you will have only one feature, that is text. From this text, you have to extract the features and decide whether the response or the feedback is talking about the service, food, and if there is any narration, then it is called as anecdotes, price and ambience. For example, you see here, food is there and anecdote is there. Anecdote means narration. See, clearly there is a narration here. And they say it is fair, the redeeming factor was the food, and which was above average. So if this response is talking about food. Are you able to understand, guys? So I have only one column, that is text, but I have multi-labels, not multi-class, multi-label. Whether the response is talking about the service, food, narrative story, price and ambience. This is the example that I am going to show you for the multi-label classification. Now we are going to import different libraries, pandas for data loading into data frame, numerical Python for handling n-dimensional array. You already know training and testing. What I have to explain to you is TF-IDF vectorizer. What is this? See, you have an input that is a text. From the text, I have to extract the features. So one technique is term frequency, TF, inverse document frequency, IDF vectorizer. What it will do? It will create a vector in the form of numerals from the text. So that is in a simple way I have explained you. If you want to learn more, you can go and explore by yourself. Then for multi-label, I have a separate package, that is SK multi-learn. Inside that there is a sub-package called as adapt. There I have one class called as MLKNN. This is exclusively for multi-label. Then one more thing, like basically accuracy score, Hamming loss for metrics. So let us not concentrate on metrics right now. Then, as I told you, we are going to use TF IDF. What is TF here? In the text, you tokenize the text, take all the words and count the frequency of every word, that is term frequency. For example, a word the, how many times it is coming? Is, how many times it is coming? Food, how many times it is coming? Like that. Then, after that, there are some words which are used in the language, but it does not carry any impact. For example, I went to the restaurant. The food is exceptional. Here, food and exceptional more valuable than the is, like that. So in inverse document frequency, what happens is it will actually calculate the impact. It will measure the weight of every given word and it will give you the impact of if each and every word. Okay. So from the data set, I apply the TF-IDF technique. I get the vector of the words, but how it will calculate the measure? It will again go with some distance metric, and finally it will extract the useful features. Okay. So basically some cosine similarity. You can go back and learn more about how TF-IDF works, right? So what I am doing here, from the entire data set, I have only the first column as my input. So what I am doing, I am taking the first column as X. First column starts with the index 0. This is 0 index. Then next column service is 1 index, index 2, index 3, index 4, index 5. So in my next line in the code, I will show you directly from here. From the first column, that is number 1 here, colon, there is nothing here. One column empty. That means from the first column till the end, take it, convert it into an array, and then put it as outcome. That is what the second line which I am highlighting here. Is this clear? What I am doing here, I am separating the input component with the output component. Then I have to extract the features. For that, I am using TF-IDF vectorizer. Then I split the data. Here I am using, for example, test size 0.3, that means 30% test and 70% training. Okay. Random state 42, you can go and see randomly when actually picking every time when you are splitting the data, it will split randomly. But when you use random state 42, almost every time it will take the same records in training set and same in testing set for uniformity. Then after splitting the data, I am transforming my training and test set with the my vectorizer. What is my vectorizer? TF-IDF vectorizer. Then building the model. Building the model is very simple. Define the class, fit the data, and then prediction. You can write one new sentence. For example, I like the food, but I hate the place. Now, for example, it gives something like this. Food, yes. Place, ambience, yes. I like the food, but I hate the place means they are talking about the food. They are also talking about the ambience. That's what it is coming here. Then evaluating the model, as I said, you can take the labels and you can go with accuracy. Sometimes accuracy may not be the alone metric which is the best possible metric. So you can go for precision recall, you can go for F1 support, right? F1 score basically, or you can also go for Hamming loss, right? There are multiple ways, right, to go with different metrics. If it is a classification problem, then accuracy, etc. If it is a regression problem, that is numerical values, then you will go with the error rates, mean square error, mean absolute error, etc., etc. Right? So this is how you will be able to implement a complete multi-label classification problem. Okay, so then I can also explain you another algorithm, that is random forest classification. Okay, I will just show you what is a random forest. I will explain in a simple words. In another 10 minutes, I am going to stop my presentation by another 10 minutes. Then the last 15 minutes, let us go with the question and answer session for the second session or the first session. What is random forest? Random forest is an ensemble technique. Then what is ensemble technique? Very simple. You know, if you want to go and visit a place, imagine sometimes we watch YouTube videos, sometimes we ask our friends who went to those places already. We gather everything and then we decide what to do. For example, you want to buy a car, you may go to the YouTube and get the reviews. You may go to the test drive. You may also ask some friends who have already bought that car. That means what we are doing, we are taking the decisions from multiple sources and finally we are taking a decision. Random forest works exactly in the same manner. This is an ensemble technique. What is ensemble technique? Sometimes one model may not give you the best result. So what you do is you go for multiple models. Here what happens in random forest, it will generate the decision trees. From multiple decision trees, a final outcome will come. For example, you see here, I am skipping the theory part, okay? I am explaining the concept. You have different training samples. From every training sample, you are getting a decision tree. Finally, you are going for a voting and taking a decision. So this is how random forest works. Let me just show you for the same iris flower how to apply random forest algorithm. Now, by default, inside sklearn, let's go and show you. Inside sklearn, by default, some data sets will come by default. You can see here. Inside data sets, there is something called as data. In the place Boston house prices, breast cancer data set, diabetes data set, iris data set, and red wine data set. So you already have the iris data set here. So in my PDF, you can see I am importing the data sets and I am loading the iris data set here. Same. Okay. The target names are Setosa versicolor virginica. The feature names are sepal length width, same. In a different way, I am explaining. That's all. Okay. And you know what is there in the data set. Then we are creating the data frame. This is also common. You are splitting the data. This is also common. Now, how to build a classifier? Random forest classifier is an ensemble learning. It is available inside the sklearn package, a sub package called as ensemble. So only thing why I am showing this to you, you should know where it is available and you should know how to use it. Now you see, simple. Call the classifier. Estimators are 100 means it will create 100 decision trees. Simple. Fit the data, predict it. How difficult it is? The code is very much similar. You have to import the class and use the method. That's all. So this is how you can use an ensemble technique also for a multi-class classification or any other thing also. For binary also you can use. Okay. Now, how to identify important features by using a different technique? Okay. See here, as I told you, there is another technique, not only pair plot, there is another technique called as bar plot. What it will show? See here, it is showing the content in a bar. What we will identify here? The feature important score, the features. See here, by this you will understand what is the most important feature. What is the most important feature and what is the least important feature? For example, sepal width has low impact. So you can think I can ignore this because it is having low impact. Why to give so many features? Here it is a small example where there are only 4 features. There can be 100 features. How you will identify whether every feature will give? You should not give unnecessary knowledge to the unnecessary burden to the model. So this is another way of identifying the important features. Then you can ignore that. You see here, I am taking only 3. Then you can go and execute. Okay. Sometimes you may get less accuracy. You see, initial accuracy was this. Then after removing the sepal width, I am getting more accuracy. Okay. Why? Because the lesser amount of features will reduce the training time and you will also, maybe you may get the better accuracy. Okay. Actually, KNN model is only there. Random is not there, but I just briefly explained you about a random forest algorithm also. So with this, I stop my presentation. I hope I have explained in a much deeper sense, and I hope you have learned something new in this particular session. Thank you, everyone. And I would like to thank Professor Kanya Madam for giving this wonderful opportunity. I am here for another 15 minutes. If you have any doubt, you please ask.
Sir,
Yes, madam.
KNN doesn't actually learn anything during the, training phase. So
I didn't. Yeah, tell me, madam.
it doesn't have any specific learned pattern like the other algorithms have, right? So
Can you please repeat, ma'am? I could not hear properly.
KNN doesn't have any learning pattern.
Okay. It
So
has.
how accurate will be the results produced by it? Because every time it has to find out the distance whenever a new class comes up.
Yes.
So
Yes,
how
ma'am.
accurate are the predictions?
Yeah. See, KNN classifier is not it is a simple to understand algorithm, but it is also a very good algorithm. In many research works, people find KNN is giving best results. For everything, KNN may not be applicable, but KNN also gives a good results only, ma'am. It gives in
Because
many of my works also,
how does it
in
have
my
the
published
impact of
works.
curves of dimensionality?
Yes, ma'am. Yeah. Uh, See, there are trade-offs between several models. Sometimes a model will give good accuracy. Sometimes it may not give. So you need to know. Like usually, what we do with my scholars and UG and PG students, we go and implement multiple things and we take the best one. Anything else?
Sir, can you list down the books you've referred for these session?
Ma'am, I have maximum referred the online resources like Tutorial Point. Maximum. I have referred tutorials point only. And I have taken a common examples. These examples, whatever I have given, these are all available in a common internet resources.
Okay, sir. Thank you.
I will share this entire PDF and the code to Professor Kanya Madam. Yeah, if there are no doubts, I think we can close the session. Thank you all.
Okay, sir. Thank you very much, sir. Thank you, sir. Nagaraj, sir. Thank you very much, sir.
Thank you, sir. I am sharing the PDF and the code with Kanyakumari ma'am. Please take it from ma'am. Thank you.
Okay, sir. Okay. Thank you, sir. Thank you all participants. Good night. Thank you.
Thank you, everyone.
Hello, ma'am. Hello. Hello, ma'am.